At this point, we can remove the code that we added just for the sake of demonstration. The functions count set, the console log, as well as the counter and the count state. So now at this point, we have a great deal of functionality in our app, but we also want to add some small details. For example, when a user's logged in and they create a given post, we want a couple of things. First of all, we want to indicate to that user that they were the one that created a given post. So maybe we want to change the color of their name to green from black. So let's think about how we would do that. Well, within app we have our posts list and we receive our posts data. In post list we're mapping over that data and we're displaying a post with the post component. So we have to go all the way down to the post component where we're passing in the user data, the user that made a given post. And here, to be able to make the color of this text green, we could add some logic for our style object, and we could set the color property to green if a given condition was met where the current user, some value called the current user, was equal to user. So that might be expressed with the comparison current user, check to see if it's equal to the user, and we can store that in a variable called isCurrentUser. If isCurrentUser is true, we can set the color to green. Now we don't have access to the current user down here within our post component, so we'd likely have to pass that down all the way from app. Remember that it's all the way up here in our app state. So how do we pass that down? Well, right now we know that the primary method, the primary pattern for passing data down into components is through props. So we'd have to create, just like we did on create post and header, a user prop, pass down user there, and then we'd need to go into post list and we would accept the user value and create another user prop on post. Then we'd go into post, and actually since we're spreading in a property here with the name user, we might call this prop current user. And then we destructure current user. So the repetition that we've introduced here might give you the feeling that what we're doing is incorrect, that there might be a better pattern to implement instead of having to pass data down through props as many levels as we're doing. We're having to pass it down 2 levels. But what's important here is the fact that this posts list component doesn't need the current user data whatsoever. It's not using the user for anything other than to just pass it down. This is something that's worth fixing. We don't want to continue to pass props into components that don't use that data. This pattern of going down multiple levels, passing props down multiple levels, is called props drilling. And we want to avoid this pattern. What's something else that we can do other than having to resort to props to pass data down our component tree? Well, there's a feature available within React that was created for just such a purpose, for allowing us to pass data throughout our component tree without having to resort to props and without needing to do props drilling with all its unneeded repetition. And this feature is called context. So how do we work with context in React? Well, first we want to create it. The way that we create a context to pass data down on is by saying react.createContext, and we do so above our component. So we'll create a context, and we can give it a value, we can give it a name, and it's going to match what type of data we're going to put on the context. So since we're passing down user data, let's call this created context user context. And once we've created user context, and every context that's created is actually an object which consists of 2 properties, what's known as a provider property to provide the data that we want to pass down through our component tree, and then a consumer property to consume it, to use the data that we're passing down. So how do we use context? Well, we use it like a component, and instead of having our shorthand fragment here, we can just place or wrap our components with userContext.provider. So now we can provide a value to all these components, to all of the child components, the children components, with the help of a special prop on provider called value. And since we're passing through the user data, we'll set that value to user. So now, within any of these components, we no longer have to use props to pass our data down. Although we still will use props for header and create post because we're just passing user down one level. But when we're passing data down multiple levels, what provider allows us to do is remove the prop that we're creating on post list. We don't have to pass it down to that component. We can bypass this, so we can get rid of where we're destructuring the user prop. We don't have that anymore. We can remove the current user prop on post, and we can go directly to post all the way down, and we can receive our current user data there. So let's also remove this current user prop that we've created. So here too we're using fragments, and the way to consume it, consume context, is in a very similar way to provider, to how we use the provider component. We wrap all the returned elements with user context.consumer tags. And now to consume the data, we need to provide a function as a child. So this might look a bit strange. So we'll comment out all of our previously returned elements at the moment. And context by default uses a pattern called render props, where we basically, using curly braces, insert a function. It can be a normal function or it can be an arrow function. And here in the return, we want to return all our JSX. And within the parameters to this render props function, we get access to the value that we pass down, in this case, user. So we can call this parameter whatever we like. In this case, we called it current user. And now we can move in all of our JSX. We can return all of that. We'll just want to remove the curly braces surrounding this image conditional, or in fact, we'll leave them because we need to now wrap all of these elements in another fragment or another parent element to make this work. So now that we have our current user, we can check to see if the current user is equal to the user that's being passed down as a prop. We can save all of our components, all three components. And the last step to be able to actually use this consumer is we need to import it from our app component. So that's why we defined it up at the top here. We want to export it as a named export, since we're already using a default export with the app component. So we want to export it and then import it wherever we use it. So we want to import it between a set of curly braces within the post file from onelevelup./app. And now we can save everything. And when we add a new post, we're logged in as read. And we see that read's username for a given post is now green. If we log in with a different user, we'll see that read is no longer green when logged in with that different user. So context is a great addition to React to be able to avoid props drilling, to be able to receive data wherever we want throughout our component hierarchy. But as you can see, setting up this render props function here in our consumer is a bit clumsy. If we wanted to have this variable from before is current user, we'd have to reformat this a bit and return the JSX and then create this, add this is current user variable above here. And you can see that our post component is getting very cluttered very quickly. Everything's having to be returned here. So we lose readability when we use a consumer like this, when we receive our context data like this. And also try to imagine if we had multiple consumers here. We would need to nest one consumer inside another. Let's say we had a post context and we had a consumer within it, and we'd have to include another render props function like this. you can see how it starts to get very difficult to read and manage. So what's a better way to consume context? Well, fortunately, there's a React hook that we can use that allows us to read from context a lot easier. So instead of using usercontext.consumer as a component, we can get rid of all of it and go back to our previous state. We still want to import user context from app to be able to use it. But instead of having to use the confusing render props pattern, all we have to do is execute useContext up at the top. We pass in our entire context object, user context, and we get back our value, which we were calling current user. Simple as that. And now we can use all of our previous code. We hit save, and we write a new post, logged in as read. You can see read's name is still green. So we have all of the prior functionality. We can consume our context, avoid props drilling, avoid our repetition, and we have a very clean looking post component. And now one more thing that we want to add to our app, in addition to indicating visually to our user that they made a post as the currently signed in user, we also want to give them a delete button to delete posts that they want to remove. So we want to add it underneath each post, provided that they are the user that made the post. Now let's think about this here. We want to include this delete button for each post. So in this case, not only do we want to figure out whether the user that's logged in is the current user, but additionally, we want to be able to update state all the way down from our post component and have it affect the state here all the way up in app. We want to remove a given post from the posts array. When it came to updating state from a child component of app, we saw how we had to use this pattern of passing down a callback, which would then update state from that child component. However, we saw the issue with having to use callback in the event that our function was recreated. So while we solved one problem here with being able to create a context to easily pass down a value, and that includes functions, to any component within our component tree, here we would pass down our function all the way to post, we would still have to wrap our callback in use callback every time. So again, we have a repetition problem that we want to avoid. So now we want to take a look at a better pattern for managing state across components rather than the lifting state up pattern where we pass down callbacks. We can clearly see its limitations here. So as compared to just using the useState hook, we're going to introduce a new type of function that's going to allow us to better manage state in a different location than just a single component. And the concept that we're going to be introduced to is the one of a reducer. So right now, to take a look at what a reducer is, I'm just going to head over to my console just to use as a kind of scratch pad for this. So a reducer is a very simple concept. I think a lot of people get confused by the idea of reducer and think that it's something complex, but a reducer is very simple. A reducer is just a basic JavaScript function, and it's ideal for helping us manage state because it's what's known as a pure function. And what do we mean by pure? Well, by pure we mean that with a reducer, we do not perform any side effects. We don't interact with the outside world. So pure means it's going to have a given input, and it always has a predictable output. Given a certain input, we always get the same output. That's the benefit of reducers, is because they're predictable and they're synchronous. So this makes for very reliable state updates. So since this is just a plain JavaScript function, let's see how to implement a reducer with plain JavaScript. So we're going to be managing within our application post state using the reducer that we create. However, let's see how we would implement the login, logout functionality that we have with a reducer. So we would create a normal function. We usually create it as a function declaration with the function keyword, and could call it reducer. But normally we call these functions according to what piece of state that they manage. So in this case, since we're managing the user state, we would call this a user reducer. And just to take a quick step back, what do reducers receive and what do they output? We talked about input and output. Every reducer receives two things. they receive a previous state as well as something called an action. And they use those two pieces of input to return a new state. And when it comes to actions, we'll see that they're just simple JavaScript objects. And if action seems confusing to you, both right now and throughout the process of talking about reducers, think of them like events. Think of them like our own custom events that we're sending off, just like we are getting it from a change event or a click event or something like that. So we have a previous state and we have an action or an event, and we use that to create a new state in a pure, predictable way. So we can add the two parameters state and action. And within a reducer, we have usually a number of conditions based upon this action. Action, as I mentioned, is an object. So here is just an example action. And an action is an object that can contain a couple of pieces of data. The first one is this type property. This type property is a string, has a value of a string attached to it, and it determines what type of state update that we want to perform. Now this is something that we configure ourselves. We determine what the type should be. But note that the convention is to always make the type string in all uppercase with any words separated by an underscore. So let's think about the state changes that take place when we log in and log out. When we call setUser, what are we doing? When we call setUser from our login component, well, we're logging in user with that username. So we might have an action type here that corresponds to that called login user. That would make sense to me. And when we pass in this object, when action, this particular action is passed to our user reducer, we want to use some sort of flow control, like a switch statement or an if statement, to be able to determine what happens if the type of that object is login user. And since there are many, many conditions, in many cases, many conditions that we can have within a reducer, we use a switch statement as compared to a normal if statement, since it's a little bit better to use for cases in which we have a lot of possible conditions. So we want to switch according to the action type. And if we have a case, if action type, action.type is equal to login user, we'll have a case specifically for that. So I'll have a case login user, we'll add a colon and a set of curly braces for our case. What do we want to do here when the action type is login user? Well, we want to receive the value that's passed along with the action, and that's going to be provided on a new property called payload. So here when the user logs in, the action is going to include the data that we need to actually log in the user. It's going to be on this payload object, which is usually itself an object. So we'll have a payload object where we're setting the username. So the username will be set to, say, read, like we've had before. So what do we do within the case? Well, we take the state, which manages the user data. And so we want to have, first of all, an initial state object. So state itself is an object, and we're keeping track of the username that we have, or in fact we called it user within app. And by default it was an empty string. What are we going to do here within login user? Well, we're going to always return a new state object. So we're going to return a new object where we're going to take the payload of username and set it as the user value. So we're going to say in this new state user is set to action.payload.username. So that's our first case. And this is fine right here for updating our state. But be aware of a couple of things. Number one, this is only going to work, this pattern is only going to work for simple values, primitive values, where we just replace one value for another. In the case of objects, we would need to copy them first. And if our state had other properties, if we had some other properties other than user, we would need to use the spread operator to spread in all of those previous state values. Just like that. And in addition to login user, we're going to have another case of log out user. And this one is even simpler. So this, let's say, is the login action, and we're going to have a logout action, and we just want to provide here a type of logout user. We don't need to provide a payload because we know what the final state should be. The final state should have user set to its initial value of an empty string. So here we also want to return a new state object where we spread in the previous state and we set user to an empty string. Pretty straightforward, even though it might look a bit complex to you at first. And then finally, we want to add a default case. If neither of these cases are met, we just want to have a fallback of returning the previous state, like that. So let's actually run this usereducer. To make it work, we need to pass in both arguments, state and action. So we'll call usereducer, pass in the initial state of user being an empty string, and we also want to pass in the login action. So if we console log the result, we're going to get back an object. When we log in our user with the username of read, what should we get? We get back an object where user is set to read, just like we would expect. And then if we log out the user, pass in the log out action, might need to refresh here. We get user set to an empty string. So this is the pattern that we're going to be using for updating state, and we're going to be able to make use of reducers with the help of a new hook called the usereducer hook that works just like this. It's going to enable us to use any reducers that we create. So instead of managing the user state, we've already got that taken care of. We want to manage our post state. And let's think of the state changes that we're going to need to take care of. We could leave handle add post, but let's use this reducer to manage all of our state. Let's handle the event that we want to add a post. So that's one state change, adding a post, and then also deleting a post, as we mentioned, from the post component. So once again, we want to use context because we want to pass our state throughout the entire component tree. So we're going to use context with usereducer. It's going to allow us to have a very powerful state management pattern across components right out of the box. So just like we have user context, we could have a post context to manage our post state. So we'll create that context. And note that you can pass context a default value. Let's provide a default posts value within an object. So on context, we're going to set property post to an empty array, just like we have here. And we also want to make sure to export it because we're going to need to access it within multiple components. We can get rid of the local post state here, and instead the first thing that we want to do is use context. So we're going to call react.usecontext. We'll pass in post context, and what we're going to get back is the initial post state. Remember how we had the initial state here for our user data? We'll also need to provide that to our reducer just like we did as the first argument. So this is how usereducer works. We'll call usereducer right after usecontext. First, we want to pass in the reducer we're interested in using. So we haven't created that yet, so I'll just pass in an empty function. And the second argument is the initial post state. And what do we get back? Well, we get back two things, very similar to how useState works. First, remember we got a state variable. We can call this state. And we also had a setter function. And the equivalent for that with usereducer is a function called dispatch. And this dispatch function is optimized for being passed down the component tree. We don't have to be using useCallback or worry about re-renders with that, or worry about the function being recreated, I should say. So now that we have our post state coming from this state variable, we need to replace posts with state.posts wherever it occurs. Actually, we're going to get rid of handle add post so we can just comment all of this out. So we just want to pass state.posts down to post list, and we can remove the handle add post function here. I'll just comment this out. So now we want to pass down both of these, state and dispatch, to our entire component tree. So we want to create another provider, this time with postContext.provider. And we'll wrap that around our userContext.provider tags. And for value, we're going to pass to the value prop an object, and this will allow us to pass down state and dispatch. And now that we're passing the state and our dispatch function, making it available to all of our components, we can go off and create our actual reducer. So let's put our reducer in a dedicated file here within source. We'll create a new file called reducer.js. We could be more specific about this and call this post reducer, but we'll just leave it at reducer for now. And again, just like we had before, we want to make our reducer a normal JavaScript function that we export from this file. So we'll call this our post reducer. It receives the previous state and the action. We want to export this with export default before we forget. And we want to set up our different cases within a switch statement where we're going to switch based on the action type. Now those two cases we mentioned were adding a post and deleting a post. So we'll go ahead and create a case for the type add_post in all caps, and case delete post, and finally a default case where we simply return state if neither case is matched for a given action. Then back within app, we can import the post reducer from /reducer, and we can replace our empty arrow function with post reducer. Now, since we're already familiar with adding a post, let's go into create post and see how to use dispatch in order to add a post in our app state. So we no longer have the handle add post callback. Instead, since we're passing down dispatch, we want to import the post context here within create post from the app file. And then we want to, up at the very top, usecontext, react.usecontext, pass in the entire context object, and we get back the object that we passed down with state and dispatch. And to easily get the dispatch function, we can use object destructuring here. We can add a set of curly braces and create a variable for dispatch here in create post. So now, here within handle submit, where we want to create a post, we can call dispatch, and looking back to how we created an action with a type, property, and a payload, this is exactly the syntax that we use for the object that we pass here. We can pass in an object to dispatch, and this is going to have a type of add post, just like we specified in our reducer, with a payload of our post object, and that will be included within the payload object as a property. So again, exactly like our example before. Now here in our reducer, dispatch is going to execute our reducer, and we're going to get that post data from action.payload.post. So this entire object is the action, and in it the payload property, and in that the post property. So this will be the new post that we want to add, and from this we want to return a new state object where the post property, remember that we had in our initial context object, we had the post property. We're going to set posts to a new array where the new post is at the beginning, and we spread in the previous posts from the previous state dot posts. Now that was a lot of work, so let's save everything. Make sure we're not getting any errors. It looks like we're getting one, and that's because I imported within create post app incorrectly. It should actually have been //app, I believe. Okay, good. So now let's try adding some post content and an image. And when we hit submit post, it should be immediately added to our post list. And it is. So we see that our reducer and our add post case are working and are updating our global post state that we're storing in our post context and making available to all of the components in our component tree. Now we're going to cover the second case of deleting a post. And that's the difficult problem that we set out to accomplish all the way down here in our individual posts. So we wanted to have a delete button down at the very bottom. It said delete, where we could click on this and remove a post with that button if we were the user that made the post. So first of all, we want to handle showing this delete button only for where the current user is equal to the user that made the post. So we can add a conditional here and say we'll only show this delete button if it's the current user. So let's test that out. We see the delete button if we're logged in as Reed and if Reed made the post, but if we log in as someone else, we don't see the delete button. Good. Now what about actually removing a given post? Well, at the moment, we are using as the key for each one of the posts. We go into the Components tab. We see that we're using just a simple index for the key. We're going to need something a little bit better than that. As I mentioned earlier, we don't want to use the index whenever we want to make changes to our list or delete elements. Otherwise, React won't be able to update our list performantly. It needs an actually unique identifier that can't be replaced later on. So for example, if we were to delete the key of 0, if we were actually able to delete this, the next post with the key of 1 would exist, and then any post added after that would also have the key of 1. So React wouldn't be able to differentiate those individual posts. So what we can do is when we create a post, we can add a semi-unique identifier. If we go into create post, we can add to the post object an ID property, and I'll set that to the current date, which is going to be very specific but not entirely unique. We can get the date down to a very small interval of time with date.now. So if we save this and add a new post and also change the key from the index to now post.id, we have a far better value to be used as our key. It's much less likely to be replaced later on. So this idea is going to help us greatly in terms of figuring out what post we want to delete. So now that we're passing down this ID property on our post, we can receive ID as an individual prop on the post component. So we can destructure ID in the parameters from the props object, and this allows us to pass the ID to delete, specifically to a function that will be called when the button is clicked. So I'll add an on click to the button, and when a user clicks on the button, we want to execute the dispatch function, which will match our delete post case. So we're going to fire off an action with the type of delete post. So here in post, we're going to need to import the post context from app as well as user context to be able to consume the post context. We'll say react.usecontext, pass in post context, and we'll get back an object, and here we'll once again destructure dispatch. So we'll add an inline arrow function to onClick. In the return, we'll dispatch an action, and to make this a little bit more readable, we'll put all this in a separate function, which we'll call handle delete post. So this is going to call dispatch and pass through an action with the type of delete post. And for the payload, let's think about what payload we want to pass through. To identify a given post, we can use the ID that we're getting. So the payload is going to be an object, the property and value of ID. Now to add the logic for deleting the post from the posts array, let's go back to our reducer. And first, in our case, it's always good to think about what is our payload going to be. Well, previously for add post, we were getting post data. Here for delete post, we're just getting an ID. So that's going to come from action.payload.id. And I like to rename the payload that I'm getting and put it in a variable so it makes it very clear what value that we're receiving. So I'm going to put this in a variable called deleted post ID. So what do we want to do here? Well, previously we were adding a new post to the beginning of the array. Now we want to return a new state object where we take all of the previous posts, and that's going to come from state.posts, and we want to filter through that array. We want to filter out any post. Where the post ID is equal to the deleted post ID. So we want to check to make sure that for each post that we're iterating over in that array, we add a condition to say, make sure the post ID is not equal to the deleted post ID. If that's the case, then we can keep those posts and put that on the new state object. All right, so let's try this out. Let's save both of our files, and we'll try submitting a couple of posts here. We'll add one post and then another. Let's actually make sure that the button is on a separate line in post, just so it doesn't interfere with the next one. So add one post and then another, and then a third, and let's try deleting the middle post. So when we hit delete, we see that it is removed, exactly that one. And if we delete the last one, that's gone, and the first one, that's gone too. So that was a lot of work that we did. It might seem very complex, everything that we covered, but really we touched upon the great power that's come with the introduction of React hooks and hooks like usecontext and usereducer. You can see when we combine them, we have this very powerful state management system. We no longer have to worry about the shortcomings of useState. We can put them together to manage whatever piece of state that we want, like we did for the post state. We don't have to worry how deeply nested they are. We don't have to worry about creating a bunch of additional props on components that don't need it, that don't need that data. We have a very robust system for managing our data right out of the box that normally would have required in the past a state management library like Redux. In many ways, this is inspired by state management systems like Redux that were usually very bulky, had a lot of boilerplate, and were difficult to set up. So what we built was fairly simple, but you can see all of the elements that we're going to be using later on when we build a complete project. You can see the elements of authentication, creating new elements, deleting them, updating them. In short, manipulating our data however we like. React gives us a ton of power, especially when we use the latest features, So now that we're armed with this knowledge, we don't have to always rely on external third-party libraries or always be learning the latest tool to come out. Once we know the essentials, the modern React essentials, and know what each feature does, what each hook does, the different concepts in React, and how everything can work together, we have all of the tools to make very powerful, dynamic, and robust applications, which is exactly what we're going to see how to make with React in this course.